Welcome back, class. So today we are going to talk a little bit about the periodic table. You should have just watched a video which discussed some of the basic ideas of the periodic table and how its organization, and a little bit about its history. And we're going to go over some of that again today and sort of hit some of the high points. So, as you should have learned, the periodic table was, in our sort of common form, was put forth by Dmitri Mendeleev in about 1870, where when he formulated what we now know as his periodic law, which essentially stated that properties repeated in the beginning of the periodic table, every 8 elements. And with the known elements of the time, right, Mendeleev, made this observation, and he put these elements that had these repeating patterns, for example, lithium and sodium, or other elements, fluorine and chlorine, right, that displayed similar properties. He stacked these into columns, and this gave the basic format for what we know today as the periodic table. So it's based on this periodic law where, again, the properties or certain properties repeat in this periodic fashion, every 8 elements in the beginning of the table. And I guess we should say when the elements are put in order of increasing mass. Now, of course, was mass at Mendeleev's time? It has now in modern periodic tables, this is not in mass order, it is in order of atomic number or number of protons, which essentially follows the same order as mass, except for in a couple of places on the periodic table where there's where you have to flip-flop a couple elements. But in generally speaking, right, as you add protons, the mass is going to go up, and so the orders are essentially the same. But atomic mass makes more sense, or atomic number makes more sense in light of what we know about the modern atom. So we have Mendeleev's periodic table, and we have this idea of this periodic law, this periodic nature of these repeating properties. And this gave us the groupings that we have on today's periodic table. So what I'm going to do now is just kind of walk through some key terms, some key ways that we sort of organize and divide up the periodic table. So first, I'll just kind of hit some of the basic vocabulary. So the rows, right, which are numbered 1 through 7 over here, are called the periods, right? And so as we get to the beginning of a new period, right, that periodicity, right, repeats itself. The columns are called groups. And those groups are organized in what we call the group numbers, right? So the first group is group 1A, and then 2A, and then we go over here, and we have 3A, 4A, and 5A. And you'll notice there's a couple different sets of numbers on here. And that is because we have sort of 2 groups of elements in the periodic table. We have what are called the main group elements, which are what I might refer to as the tall parts of the periodic table. These were elements that follow very closely this periodic trend. And then there are these elements in the middle, which we call the transition elements or the transition metals, which do not tend to follow the periodic trends in terms of properties as, as good as these main group elements. In fact, most of these, if you were to go across, these columns on the periodic table, there's not a whole lot of difference between the actual behavior of most of these elements. So we have periods and groups, right? Periods being the rows, groups being the columns. We have the first 2 columns and the last 6, right? So these 8 columns are known as the main group elements, the taller ones. And we have the 10 columns in the middle, which are known as the transition elements, the transition metals. Now, when we speak about the main group elements, the group number becomes important. And so the group numbers go between 1A over here and 8A on the far right-hand side. And so we go 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. And this is often how we refer to the elements, right? We'll say it's in group 6 or group 7, right? We almost never use group numbers when we talk about the transition elements. We just say it's a transition metal. But when we talk about the main group elements, we need to specify the group number. Now I will make special note here of hydrogen, because while traditionally hydrogen is put in group 1, it doesn't actually belong in group 1. It doesn't actually belong in any group. It's just traditionally put in group 1, but it doesn't share common properties with the rest of the elements in group 1. Right? So group 1 in reality starts with lithium, and the repeating elements go down from there. So hydrogen is kind of a free agent in the periodic table. It doesn't really fit in any particular group. We just most often will put it at the top of group 1. So this is one way that we can organize the periodic table. Now, if we continue to look at this, there's some other sort of vocabulary that we should look at. So some of these groups have specific names. So we'll look at group 1A here. These are what's called the alkali metals. We have group 2A here, which are called the alkaline earth metals. And then group 3A through 6A don't have any specific name that we call them. Group 7A here is called the halogens. And group 8A, right, this is the noble gases. So we have 4 groups that have specific names associated with them. And the reason we go through all these things is we need to be able to recognize what elements are a part of this. So if we're talking about chlorine, for example, element Cl here, we need to understand that it's part of group 7A, it's also part of the halogens, and it's a main group element. So we need to be able to categorize these into where they're located in the periodic table. So as we start to get a feel for navigating the periodic table, we're going to look at one specific way that we can group the elements based on a specific property. And we're going to look at metallic characteristics. So if we think about metals, metals are located on the left to middle part of the periodic table. So all of these here, these tan elements here, these are all metals. So the vast majority of elements in the periodic table are metals. Now, while we're doing this, I want to introduce a couple more vocabulary words we have these two rows down here in the bottom of the periodic table that are traditionally put that. Now, they belong in periods 6 and 7, right? So they fit right into here, and so these bottom two periods are actually much longer, or in other words, the repeating pattern is longer, right? So if you notice, in the beginning of the periodic table, it repeats every 8 elements, and then every 18 elements, and then every 32 elements. So we add another 14 elements into there. And these two groups of elements are called the lanthanides and the actinides, right? And they start with element La, right? That's where lanthanide comes from. And element Ac, that's where actinide comes from. So the lanthanides and the actinides, and these are part of the transition elements. Sometimes they're called the intertransition elements, but they all fall into this, what we call the transition elements on the periodic table. So we have a bunch of metals. About 75% of the elements on the periodic table are metals. We have nonmetals, right? These are the ones labeled here in green, and they make up the upper right-hand corner, upper right-hand part of the periodic table, right? Now, hydrogen, of course, is usually placed over here, but it is clearly falls into the non-metal category. Now, what's different about these, right? Well, if we think about metals, right? What are some of the big things we think about metals? We think about them being as conductors of both heat and electricity. They are solids, right? All the elements, all the metal elements are solids except for mercury, right, which is a liquid at room temperature. And, and other things that we associate with metals, right? They are what we call malleable. It means we can bend it, we can pound it into shapes, etc., right? We can work with them. And shiny, and other things that we might consider the properties of a metal. Nonmetals, right? If we look over here, nonmetals, right? These are going to be insulators. So they're non-conductors, right? They don't conduct heat or electricity very well. They are, for the most part, brittle, right? We can't bend them. They're brittle if they're solid form. They exist in all three phases. Most are gases. There's one liquid and a few solids. Right? The one liquid being bromine here. But a lot of these exist as gases. And so they have certain unique properties. Now, one thing I will also add to this is something we talked about last time was some of their chemistry, right? One of the things that we learned about metals, right, is they like to form positive ions. And nonmetals, they like to form negative ions. So we start to see these commonalities in properties depending on whether they have metallic characteristics or non-metallic characteristics. And then finally we have a select group of elements, about 8 of them, that make up this sort of diagonal borderline between the metals and the non-metals, and these are called the metalloids, or sometimes called semi-metals. And these are intermediate, right? They have properties of being what we refer to as semiconductors. So they don't conduct as well as metals, but they do conduct. And being semiconductors, the conductivity is somewhat controllable. So this makes some of these elements particularly useful in electronics, right? What we think about when we use the term semiconductor, right? Specifically, we think of silicon in this region, but we have germanium and antimony, and these are all have some application a lot of times in these semiconductors. And their other physical properties are somewhat like a metal, somewhat like a non-metal, depending on which one they are. They may be shiny like a metal, they may be brittle like a non-metal, So they have intermediate properties, right? They sort of bridge that gap between being a true metal and being a non-metal. So now we have some basic navigational tools for the periodic table, right? We can categorize them in terms of metal or non-metal, what group they're in, if they're a main group or a transition, if they're in a specific name group like an alkali metal, etc. And we need to be able to do this. So we're going to bring our study of really atoms and elements to a close here. And in the last section, we're going to shift gears and talk about how we now take what we understand about these atoms and start to quantify them, right? How do we start to count atoms, if you will?